Hello everyone, my name is Sebastian Serasti. Uh, I've been working as a data scientist and machine learning engineer for almost 5 years. I've been doing different kind of projects applied across different kind of industries such as airports, retail, banking, and right now specifically I'm working in pharma. Today we are going to be talking about advances in natural language processing, why natural language processing is so complicated from my point of view, and probably the most trending topic, the most trending applications that you can find out right now. So this is the agenda that we prepared today. So let's move on. I'm going to start with a quick introduction. So the thing is, natural language processing essentially different techniques, models, or different data process that you might be needing for collect a text and process in a way that a machine can understand it. Why this natural language process is really, really important? Because at the end, people, I mean, we as a human, through different years of evolution, we've been able to create a language, I mean, natural language, and understand it, and not just to communicate ideas. The language also has helped us to understand and even to do even more complex things such as mathematical operations. But the truth is, machines has not been built around this idea. Machines are just being able to understand zeros and ones, like this binary language. Why? Because basically inside the machines, at least right now in the classic computation, you have zero if there is no electricity going through the circuit, and you're going to have one if the electricity is passing through the circuit. So that's a pretty big challenge that we need to overcome, because at the end we need a way that we are going to be able to represent the language in a meaningful way that is not just letters saved into our memories. So I'm going to start with an example because I want to highlight how important is natural language processing right now. So my question for you here right now is, how much text data is produced in a company daily just for a single employee? You might be thinking that just one text document per day, or whatever statistic that comes into your mind. But the thing is, in average, an employee is producing 3.5 text documents daily. So we're gonna continue with this example, but to put this into a more context, I'm going to give you this small table. And here in this small table, you can see specifically in these two rows that just one employee at the end of the year is being able to produce more than 1,000 text documents just in 1 year. But the amount of information that is actually produced by the entire company, it's a lot of information. In fact, it is 63,000 files that are produced yearly. That pretty big amount of information, that is pretty big, overwhelming, and makes this so complicated for a human to be able to label this one by one. And why is important label this information? Because at the end you don't have governance of what kind of data do you have inside these text documents, because some text documents maybe anyone might have access to this, but other kind of documents might be more kind of restricted, and just people with high privilege with high privileges in the company, I mean the C-level people in the company, those people should have access to this, because those text documents might be agreements between your most close partners, maybe also might contain information about bank accounts, And if you don't know where is specifically the information, probably you're gonna be exposed into different data leakages problems. So you can overcome this basically with natural language processing applications by creating a machine that can label one by one, and in just few hours you're gonna have at the end what is a publicly available text document. This one is just for the employees, and this one is just gonna be, for example, just for the C-level people in the company. So with this example, at the end, I think it's clear the goal of the presentation and NLP has been clearly explained. At the end, in any kind of NLP model or algorithm that you're going to be using, you're going to be needing, or your main input is going to be a text, as you can see here. The goal is to have a defined output. The output can be anything that you need. The output might be a label, as we did in the previous example, or also this can be even more text, because you can translate the sentence from English to Spanish, but also you can translate the sentence from English to French to Chinese, or whichever language that comes into your mind. So another question that probably you might be thinking about is that maybe is NLP just applied into text classification? And the answer is no. In fact, right now NLP is so popular because with these new user interfaces with chatbots, uh, you can have personal assistants for different kind of tasks. They can help you to search information. They can draw images for you, and they become pretty popular. In fact, if we can pay attention across the different tech industries products, another, I mean, pretty popular products such as Facebook or Instagram, those products employed several months to reach 1 million users, but ChatGPT was so popular that just in 5 days was able to reach this amount of users. In fact, right now, ChatGPT is not the only solution available in the market. You can have or you can use other competitors, for instance, Claude. I really like Claude because, at least for me, for my coding task, Claude is pretty smart. You have also alternatives such as Mistral and also Gemini, which is powered by Google. And also, another interesting application that is being done right now is the construction of NLP agents. NLP agents allows you through just natural language processing, or just an text as an input, allows you to orchestrate different tasks such as saving information into databases, producing billings, or anything that comes into your mind. The most useful application, at least from my point of view, is in sales. At least I think in Ecuador, and also it can be applied into Latin America. WhatsApp is one of the main channels for selling products, but for people selling the products by WhatsApp, it's a nightmare. Why? Because if you're gonna be selling something by WhatsApp, probably you're gonna need to double check if people makes you the bank account payment. Also, you need to give the people the billing. You also need to record the information about the billing and so on. The best thing of creating agents right now is through any kind of application that you might think it's gonna be having this kind of interface like a chat. You can have these different triggers which will allow you to launch different process, as I said before, such as saving data into databases, emitting billings, and so on. In fact, right now, if you are more curious, you can build these agents with frameworks such as N8N and also LangGraph. I'm going to continue with this more technical explanation. I'm going to start with traditional NLP. Why I call this traditional NLP? Because over the probably last few years, maybe over the last decade, there has been a new approach of using neural networks, but NLP is not, NLP is not a field that has been studied just the last few years. This NLP has been studied for several decades. And that's the reason why I tell traditional NLP, all the works and efforts done before the last decade. So the real problem that we are facing every time in NLP is how can we represent language into numbers? That's the same question that I told you at the beginning. How can we represent this? Because again, we are humans, and it's our nature behind, or it's in our brain that we can understand the language, and in fact you can understand probably fully what I'm talking right now, probably with a little bit of troubles because of my Latino accent, but that's not the main trouble, or that's not the main point. The main point is you can understand what I'm talking about. But if we want to put this into the computer, that's going to be so complicated, because at the end the computer just is just being able to understand zeros and ones. So to answer this question, I'm going to give you a little bit more of context, because at the end NLP needs more something like a naive representation, or just a naive operation. Because in supply chain, for example, if you want to do something such as resource planning, inventory optimization, at the end, those operations just need simple arithmetical operations. For example, if you have a quantity for an item, you just need to add how many items are going to be coming the next week, how many items did you sell the last week, and so on. So at the end, your operations are pretty easy. You don't need something that is pretty big complicated. I mean, this is not rocket science at the end. It's just basic mathematics that follows a specific logic. But in NLP, for example, right now, an easy application, I think, at least from my point of view, is identifying if an email is ham or spam. Because, at least in my point of view and in my spam folder, I've seen that a lot of people, and probably the right word is a lot of hackers, uses this kind of messages with employees words or of passages, something like, hey, I'm a guy from an African kingdom, I'm gonna give you free money, and so on. But at the end, even though there's something like a pattern in the spam folder, specifically people who's gonna give you free money, people who's from charity, and these kind of things. The problem is the same words that are coming into your spam messages. The same words can also go into messages that are not truly spam messages, and that's the reason why sometimes you might miss an important email because was wrongly labeled as an spam. So coming back to the original idea, defining a way to represent the language is a pretty big, complicated task. It doesn't involve just counting which words do we have and how many times there are the words. We need a more holistic point of view and a representation of what do we have behind. So I'm going to start with a simple exercise. In this case, I'm gonna do an explanation of a traditional NLP representation, which is called bag of words. What is bag of words? You might be thinking about. Bag of words is a technique that basically creates a vector to represent a text. This vector needs to have the length of all the possible words that you're gonna be having in your language. For example, here, just an example, in English, you might have 60,000 words. To be honest, I don't know how many words you might have in English, but this is just an example. So again, you identify how many words you're gonna have in your language, and you create the vector, and each position of the vector is going to represent a word. After that, you are gonna be starting to filling and adding based on how many times all the possible words are appearing into your text. For example, as you can see here, sorry, as you can see here, the word number 1 is happening 4 times, and the word number 3 is happening 3 times. So that's the main idea of how bag of words is really working out. But as you can see in the last slides, bag of words seems to be pretty easy. But behind bag of words, you have specifically 3 main issues. The first one is memory overloading. Why this is gonna happen? Because at the end, if you are gonna be creating every time that you are gonna process a text, a vector of 60,000 values, that's a pretty big data structure that you need to build. So that is so complicated, and probably at some point, if you are processing many cities, many text inputs, you're gonna be killing your computer. So that's a pretty big issue. Also, another problem that we are facing with bag of words is that bag of words is a dispersed representation. What is this? The point is, as you can see here, every time that we are talking about, we are not using all the words that are possible into our language. So at the end, you're gonna have less than 1% of all possible words in the vocabulary, but the rest, I mean the 99 words that we are not using, always are gonna be filled with zeros. So at the end, this is not mathematically and from my point of view meaningful, because you are just using few positions of the vector to collect which words are actually into your text input. And also at the end, even though you are collecting which words are appearing into your input, the other problem is not enough having how many words you're gonna have into your text. At the end, you might have the same sentence, but if you are not keeping the semantic meaning of the things, you are in trouble. Because, for example, you might have sentences like, I don't know, maybe Sebastian is crying, but I know Cesar is helping them, or something like this. You might have the same sentence, but just changing the order of the two names changes completely the meaning, because the first name is meant to cry, but the second guy is meant to helping. So you need to keep not just who is in the sentence, you also need to keep who's crying and who's helping at the same time. So as I told you, for the same sentence, if you are just counting how many times the words are appearing in the sentence, probably the vector is going to be the same. So again, I'm going to give you another example of why NLP again is so complicated. And here we're gonna have two sentences. In this case, I've collected, this is just an example. And here we have, and here our goal is to being able to classify which text is talking about a leader of a terrorist group. Sometimes people is crazy and start writing pretty weird things in social media. And you need algorithms that can ban these posts because they are hateful speeches, they are racist speeches, and so on. So the idea is, again, we're gonna be doing this exercise to be aware of how complicated is NLP, specifically with traditional representations. Just give me a sec. So I'm going to continue. So the thing is, when we are in traditional NLP, the way that we can represent the words, it's a trade-off, because if we are going to be collecting all the possible words that we have in our vocabulary, we're going to have pretty big representations, and those are going to be so inefficient. So one option to avoid the memory overloading is just working with the most common words, maybe just 2,000 words on something like this, but and also selecting not just all the information that is available in the text. And here we have two sentences. The first sentence is Pedro is a happy guy who lives in San Francisco. And the second sentence is today the gang led by Pedro committed a new crime in Mexico. The first sentences, the first sentence means or is referred with a guy who's just uh, living somewhere. And the second one is the one that we're interested identifying who's talking about the terrorist leader. So if we start trying to classify the two sentences, you can think that maybe what if we try to catch the word Pedro? Okay, we can catch the word Pedro. That's gonna be until some point useful, but just using one word is not enough, because at the end both sentences has actually the word Pedro. So it's not enough still. It's not enough information, as you can see in the green color. So we need to capture even more information. So what if we collect two words that happens after Pedro? So as you can see here, the verbs are appended into our data, but this is not still information. In the first sentence, we are just using Pedro is, and in the second one, we are using Pedro committed. That's not still information that we are gonna be pretty aware that we are classifying it well. So what if we continue with three words? The thing is that's not still the good enough information. If we move on into four words, again we're facing the same trouble. So uh, as you can see here, at the end, how much information you're gonna be using, it's completely a trade-off. And if you have more information, probably you're gonna have better results, but also you're gonna have more problems in kind of data structure representation and the computer resources that you are actually be needing. So just as a summary of traditional NLP, in traditional NLP, at the end, it doesn't matter which technique you're gonna be using, because you have other alternatives as bag of words, but at the end, it is the same. You're gonna have a vector which represents which words are available in your sentence. Um, Also, if you start to using more words, you're gonna be having bigger representations, and probably it's more likely you're gonna be running out of memory. So, and the third point is, even though in the last examples we tried to analyze how many information, how the information is collected and so on, we're still having this problem of the representations should also keep the semantic meaning of the sentence. As I told you some slides before, we can have the same words in two different sentences, and those two sentences might have totally different meanings. So that's something that we are not being still able to do and to catch. So I'm going to start with deep learning. Again, as I told you before, deep learning has been developed for the last decade, but deep learning became so popular because it changed the mind and the way that NLP was traditionally doing. But before making the explanation of how NLP is actually deep learning, is actually used in NLP, I'm going to make a pretty simple explanation of what is deep learning. Maybe here is people that is not actually aware of what is deep learning, what is inside of deep learning. So inside of deep learning, we have three main concepts. The first concept is a neuron, the second is a lawyer, and the third one is a network. So what's a neuron? The neuron is just an emulation of biological neuron. Probably, if you can remember your biologic classes in the college, uh, or even I think this is given in the high school, you can remember that a human neuron has this structure. This structure is built with dendrites and a nucleus and also an axon. The dendrites collects the information or the different the information that comes from all, other neurons. This information flows to the nucleus, and in the nucleus this information is processed. Once the information has been transformed, this is communicated to other neurons through this axon. So, making this analogy in artificial in artificial neurons, we have something which follows the same idea. At the beginning, we have something like dendrites, and in this case, we collect the information and summarize the information through a linear function. Once we have collected all this information, this passes by an activation function. The activation function breaks the linearity of the linear function and produces a more elaborated output. And this output is propagated to other neurons. But sometimes using just a simple neuron is not good enough. So that comes the concept of a lawyer. A lawyer uses several neurons at the same time, and the information, the inputs, goes to all the neurons, and each of the different neurons at the end is gonna be learning different kind of things. One neuron might be able to understand one pattern, the second one might be able to understand a different one, and the final one is gonna be learning a totally different thing. But at the end, each of the different neurons are going to be able to catch the different patterns that happens in your data. And through these patterns, at the end, you're going to be able to predict a desired output. But sometimes, again, just using a lawyer is not enough. So again, what if we stack different lawyers one by one, as you can see here in this slide? That's the main idea of a neural network. The neural network basically is just built with different layers, and the information goes from the left side, as you can see here, and goes to the right side, as you can see here. In the left side, the information is fed into the neural network, and as it flows to the right side, the information is processed in the different layers, as you can see here. And the idea is at the end, in the last layers, the information is going to be more processed and going to be and it is going to be more useful in order to predict the output that you want. So that's the main idea of a neural network. But you might be thinking that this mathematical fancy stuff, it is fine and nothing else. But the thing is, deep learning has become even more important that you might be aware of, because deep learning has been able to overcome the human level across different tests. In this case, I'm showing you a benchmark which is called ImageNet. This benchmark is specifically not being used in NLP, but is pretty popular in computer vision. In computer vision, this benchmark is used to classify across 1,000 possible objects that might be available in your images. And the point is, at the beginning of deep learning, the first attempts of architectures were worse than the human performance. But the last few years, the architectures based on Inception, ResNet, were able to even have better performance than humans. So this is not limited just in computer vision. In fact, right now also it also happens in natural language processing. It is being able to reach in different tests same human level, and in other tests it is being able to overcome. And also in others is even worse. That's not perfect. But again, coming back to the NLP applications, Transformers are the main reason why NLP became so popular the last few years. Specifically for this study that was carried out by Google. Google developed this paper and this architecture also inside the paper, which is pretty, pretty interesting because the paper is called Attention is All You Need. And inside this paper, they developed a type of neural network architecture, which is called self-attention. But the main point of the interesting thing to talk about is Google was the first one who developed this technology, which are the transformers. However, OpenAI was the first company who was able to build an actually useful project based on this architecture and was able to release into the market. And right now, we know this architecture as ChatGPT. I know that probably some of you didn't know that ChatGPT is not a transformer, but that's the main reason at the end ChatGPT has the T letter, because ChatGPT means a generative pre-trained transformer, and that's what I'm be talking about. So as you can see here, the transformer architecture has these different blocks. And at the end, the idea of a transformer architecture is that you're gonna have a head which is called an encoder, and also a head which is called a decoder. The encoder basically collects the raw information, and the decoder processes the output and generates in an autoregressive fashion the outputs. But I know that this is overwhelming, even for me, considering that I'm a machine learning engineer, that I'm gonna be breaking this down into small pieces and concepts that anyone might be understanding. So the transformer architecture is built basically with 7 steps. As you can see here, in fact, 4 of those 7 steps, and the 5, 6, and 7 are here. But I'm going to start with the first step, which is the tokenization. What is the tokenization? Well, essentially, a tokenization is a process at the beginning of the transformer architecture, where the text input that you're giving into your model is mapped into numbers. Basically, each possible word that you might have in the language is mapped into a number, and you're gonna be having a vector, something like this, but this vector is not gonna have the length of the entire vocabulary as we did at the beginning with bag of words. This vector is just gonna have the words that actually occur in your sentence. Second step is something what is called semantic embedding. This looks like fancy stuff, but it's not actually, because a semantic embedding is just a small neural network or a stack of the neural network that is being used to transform these numbers into a different kind of numbers that are going to be meaningful in a way that, for example, as you can see here in this picture, the vector that we're going to have for the word king and man are going to be pretty close, and also the vector that we're going to have for queen and woman are going to be so close. That's the reason why you see even in the same color. And something similar happens if we are dealing with the same verbs, but for the same verbs are just changing the conjugation. At the end, the semantic embedding tries to transform this numerical representation into a way that this representation catches the semantic relationship of what do you have inside and your text. So another main trouble that we're facing is, okay, we catch what word do we have, we catch the meaning of the different words, but also we need to keep what's the order of the different words. In this case, it's applied something which is called a positional embedding or encoding, or also positional embedding encoding. It depends on what paper or book you are reading. But the point is, at the end, you're gonna be having a vector that also it transforms the previous output in a way that now this input collects the way that words comes into your sentence. Specifically, if we take a deep dive into what happens behind, it's applied a sinusoidal and a cosinusoidal function. I'm not gonna be talking about this too much, but for anyone who's interested in this, here you have the equations. And after that, it is applied the novel uh, architecture that made Google. In this case, it's applied the self-attention mechanism. But the thing is, the self-attention mechanism is really useful because even though we were able to see what words do we have, what's the semantic meaning, what's the order, we also we need to we need a way to give a model. Uh, I mean, sorry, we need a way to give to the model some kind of relationship between the different words. I mean, as you can see here, we have the same sentence, but even in the same sentences, when we are, for example, referring to the word it might be more related with the words that you can see in green colors, and it is not too much close related with the words that are in the orange color. So that's the idea of the self-attention mechanism. We need to transform the vector that comes from the positional encoding, and this transformation should be able to catch the importance across the different words, because if we are dealing with a pretty big text, probably the first word doesn't have too much relationship with the last word, but probably the first word has much importance with the second word. That's what I meant. And the idea of this is applying several times. And why this is needed? Because if you apply several times over and over, you're gonna have different heads of attention, and in each of the possible heads that you're gonna have, you're gonna be learning different things. For example, one head is gonna be specifically focused on understanding the relationship between all the words and the adjectives, and the second one is possibly gonna be more focused on understanding the relationship between the articles and the rest of the words that are present in your sentence. So that's the idea of attention, the attention mechanism. After that, we're gonna have the decoder. The decoder is basically pretty similar to the encoder of the. I mean, it's that's the decoder has all the components that I already explained before, but the small modification is that happens in the decoder. It's the decoder makes some modification into the self-attention mechanism, and as you can see here, the self-attention is applied in all the directions and all possible words. In the decoder, it basically collects the information that comes from your encoder, but at the same time applies other kind of attentions. In this case, is applied casual attention, and also it's applied cross attention. Depends on which architecture you're using, and also it depends on what you are doing. But at the end, in the decoder, the idea is calculating the attention just from the left side to the right side, because at least in our language is the way that we produce the words, and also that's the way that we write. As you can see here, I don't know, maybe with a random sentences such as I'm a guy from Ecuador. Again, if you write this down, you're gonna see that you start doing the things from the left side to the right side. And after that, after you apply the different transformation stuff, the attention mechanisms, encodings and embeddings and so on, you're gonna have just an output. But the thing is, this output is not completely useful. We need a way that we can fully understand what's the meaning of the output. So we need to transform this input into something like a matrix that contains all the probabilities across all possible words that we might have in a language. And we can do this with a mathematical function, which is called a softmax function. And at the end, we're going to have a vector, which has the length of all possible words that you have in vocabulary, sorry, in a language. But at the end, you're going to be selecting and choosing the word with the highest probability. And the point is, all this mathematical stuff that I explained to you is just to produce one unique word. And that's the main reason why the different GPT personal assistants, code assistants, and so on are so expensive to run. All the calculations, all the explanations that I already told you are just needed to produce just a single word. If you're gonna have an entire output which contains several words, this is gonna be pretty time consuming and needs an iteration in an auto-regressive way over and over and over until you have what you want. In fact, this is very 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 expensive in terms of computing resources. So, as a summary, at the end, if we start using transformers, just to remember, we were able to have a vector that it's going to represent what is the most likely word that is going to happen after our input. Also, the representation that we are doing is small, but because the model uses different concepts and different things, we're not gonna be doing a memory overloading, because in terms of how many how big is our data that we're saving. In this case, probably we're having a memory issues because our model is pretty big. It's not the fault of the vector, is what I meant. And at the end, again, as I told you, with the different um, components, we're gonna have a vector that actually has semantic meaning, and that is pretty important. And that's something that techniques such as bag of words, they're not being able to do this. So I'm gonna be talking about one thing that became so popular, specifically at the point that I did the slides. Probably right now, DeepSeek is not too much trending topic in social media, but some months ago, actually it was. And I think until now, DeepSeek is something that we need to take a look and understand why DeepSeek became so popular. Because in social media, all people was talking why DeepSeek is popular. Hey, use this, but no one's really give us a useful explanation of why DeepSeek is important. So and became popular. Sorry. The two main components of why DeepSeek became so popular, the first one were the architecture, and the second one was the training. So what happens in the architecture? The thing is, when we are doing in the transformers the multi-head attention mechanism, every time that we're running the model, we need to calculate three big matrices, which are called the key, query, and values matrices. And the point is, they are pretty big matrices. And as I told you again, we need to run this every time that we're producing a new word. And the point is, at some point, we're gonna be having memory issues. And as you can see here, every time that we are, in this case, this is a visual example, every time that we are using and giving to the model a new word, this is being calculated over and over and over. And I remember that when ChatGPT was released at the beginning, it was just contain a context window around 4,000 tokens. And right now, even you can find even more powerful models. Right now, that's not the main limitation. You can have models with a context window, I mean, that can use bigger sentences as an input. I don't know, like 60,000. I saw some months ago a model that can have 100,000 words as an input. So that's a pretty vast amount of information that we need to process. And the point is that this is, as you can see in the left side, this is the thing that happens when we are dealing with traditional transformers. When we are using the common multi-head, or the traditional multi-head approach. Every time that we are running and getting a new word, we need to recalculate everything with the context window. I mean, the inputs that we're giving to the model and also the output that is being generated. And this is so inefficient, as I told you, in terms of computer resources. And a way to reduces the computational burden is to apply something like a cache mechanism. In the cache mechanism, at the end, we're gonna, in this case, I'm doing a multi-query cache mechanism. In this case, I'm calculating something like an average of all possible values in the matrices for, again, sorry, for values and key matrices. And at the end, I'm gonna have just one matrices for values and keys. And I'm gonna be just calculating the matrices for queries. And this is very, very useful. In fact, this speeds up the inference of across all transformer models. However, it also involves a trade-off, because if we uh, apply this mechanism, we're gonna be decreasing the performance of our model. So what DeepSeek did behind is, instead of calculating those the values and keys matrices through vectorial and matrices operations, what they did is basically creating a small model that you can see here. And this small model, in fact, this was an encoder. This model was able to reconstruct the values and keys matrices. Through this, it reduces the memory needed in your computer to run the model, and also this helps to improve the inference time, because that's gonna be more efficient. That's the most likely reason. In fact, if you're gonna be watching the prices of running a DeepSeek model, at least when DeepSeek was released, was several times cheaper than running other models, such as the OpenAI or Mistral models. And the second thing that DeepSeek made to gain this popularity was using a reinforcement learning approach. So what is reinforcement learning? Reinforcement learning is a paradigm. Is something like a philosophy, is what I meant, sorry, of instead of having labels and teach, okay, if you have this input, I'm gonna have this output. Instead of having this, you evaluate the performance of something. For example, it's the way that we can, when we are a child, I think that's the way of we can learn to understand the environment. For example, I don't know, if I were a child, probably I will start to explore my house. And if I start to touch the oven, and probably if the oven is baking, I don't know, bread or something like this, probably my fingers gonna be injured. And after that, I got the response in my fingers, and probably the injury. and and I'm gonna be able to understand that this is not the right way to do in my house. So in this case, I didn't get a reward, but probably if I were a child and I was constantly getting good notes in the school, probably my parents are gonna be giving me, I don't know, like gifts, or maybe stuff that I want. So that's the way that we as a humans are able to understand what is good for us and what is bad for us. And this similar approach of interacting has been doing in the last few years to train a generative pre-trained transformer, or also known as large language models, or just LLMs. So you collect an input, the LLM produces a response, and here you are going to be using an evaluation function. This evaluation function, what does behind is just probably a human reader that is analyzing if the answer is good or bad. And after that, this human are gonna be giving a reward. The reward is gonna be positive, negative, zero, based on what's the goal of the input. But the thing is, even though this can be done by humans, that is pretty time consuming, and also uh, sometimes even the same task might be good for one human and also might be not good for other human. And that is why training an LLM is more is tends to be a fuzzy task. I mean, sometimes it's good, sometimes it's bad. We don't actually know. So DeepSeek, to overcome this limitation of having the human in the loop and sometimes becoming a little bit fuzzy task, it replaces the training with simple tasks that we can verify so easily. For example, if we ask a model how much is 2 plus 2, probably the answer is gonna the plausible answer is 4. But if the model is gonna giving us 5, that's not what we want. So that's the main idea of why DeepSeek was also became so popular in the way that it changed the training of large language models. And that's all I think. I have here I've prepared a small demo for you. Let me open this. Just I think I need to share my other windows. Just give me a sec, please. Okay, I'm gonna share again my screen. I think right now you're watching my browser. And the thing is, one trouble that people has been complaining in social media for the last few months that I've seen is specifically in the context of the academia. Sometimes you're required to write an essay, but the main idea of writing an essay is you have to be inspired by yourself. You have to write the things by your own. That's the goal of writing an essay. However, some today you can do this by ChatGPT in just a few lines of prompting. So one thing that I've decided to do is creating an application. This application is trained to identify basically if a text was written by a human or by an AI. In fact, this application can also give you an explanation of which words are more likely to use by an AI. So here I asked to ChatGPT, just give me an essay about why electric cars are the future, and in this case I use 1,000 words, and I'm gonna just be copy and pasting the essay to see how the model works. And if everything works fine, probably we're having the response that we know, that this essay was actually written by an AI. And in fact, this is giving you the main words that are more correlated of human patterns, and also the more plausible words that are more closely related with an AI patterns. And as you can see here, that's a pretty interesting application. I think anyone who might be interested in this can take a look on this. In fact, you can see this in my Hugging Face profile, and that was everything, I think. If anyone have a question, I think that's the way to do this. And also, if you are interested in following me, there is my social media. You can scan my LinkedIn account in this QR.
Thank you, Sebastian, and thank you everyone for joining. It's a really interesting topic for the ones that maybe we don't know much about this topic. So That was really great. Just a quick reminder, this session was recorded and we'll be sharing the recording too. So if you can rewatch it or catch up if you miss any part, and just stay tuned for the next session. And again, thank you, Sebastian, for your time and for the valuable insights.
Okay, you're welcome.